Hey guys, in this video I'm going to go through a very tricky transformation matrix problem that involves trig functions. Now reading the question at first, it looks pretty daunting, but all you need to know is one initial step to set up the two functions, and then you just follow the standard process to solve for the values of a, b and c. And so reading the question, we've got the transformation t, defined by the given matrix, maps the curve of y equals minus 2 cos 3x onto the curve with the equation y equals 3 sine 2x, where a is a number from 0 to 2, b is from 0 to 2 inclusive, and c is from 0 to pi on 3. Find a, b and c. Before we start solving for a, b and c, this first added step that we need to apply happens when you're transforming trig functions, going from a sine function to a cosine function, or going from a cosine function to a sine function. And what you need to do is rewrite one of these functions so that both the original and the transform function are either both sine functions or both cosine functions. One way to do this is knowing that cos of x is equal to sine of x plus pi on 2. Meaning that if we translate the sine function pi on 2 units to the left, we're going to get the cos function. And so this means that cos of 3x is equal to, or the same as, the sine of 3x plus pi on 2. This means that we can now write the original function y is equal to minus 2 cos 3x as y is equal to minus 2 times the sine of 3x plus pi on 2. And we can write the transform function in terms of y dash and x dash as y dash is equal to 3 times sine 2x dash. And now that we have both the original and the transform function both as sine functions, we can follow the standard process to solve for the values of a, b and c. And so what we need to do now is expand the transformation matrix. This is going to give us the coordinates x dash is equal to ax plus by plus c, and y dash is going to be bx minus ay plus 0. From here, we need to rearrange the original and the transform function to make it in equivalent form. In other words, anything that affects the y values should be with the y's, and anything that affects the x values should be with the x's. And so the original function is going to be y divided by minus 2 is equal to sine 3x plus pi on 2. And for the transform function, this is going to be y dash divided by 3 is equal to sine 2x dash. And now we have this in equivalent form. And now we equate the y's and the x's. And so we're going to get y over minus 2 is going to equal y dash on 3. And we're going to get 3x plus pi on 2 is equal to 2x dash. From here, we need to make x dash and y dash the subject. Making y dash the subject, we multiply both sides by 3, and so y dash is going to be 3 times y over minus 2. Making x dash the subject, we divide both sides by 2, and so x dash is going to be 3x on 2 plus pi on 4. And the final step is to equate the coefficients. We have two equations for x dash and y dash. And so the coefficient of the x term is going to give us the value of a. This constant is going to give us the value of c. And we can rewrite this as plus 0y. And so the coefficient of the y term is going to give us the value of b. And so therefore, the value of a is equal to 3 on 2, the value of b is equal to 0, and the value of c is equal to pi on 4. And that's it for this question. If you can learn how to answer this question, then you should be able to answer pretty much any other similar transformation matrix questions. But if you want to learn how to answer more transformation type questions just like this, then log into the Maths Methods Club, and from the main topic, select Functions and Graphs. And then from the subtopics, select Transformations. Transformation questions have been asked in almost every single exam in Year 12. So start by going through the take-free questions and then the multiple choice ones, and then the extended response questions. And you can do this by selecting tech-free or multiple choice or extended response from the question type. And that's it for this video. Good luck, and I'll see you guys in the next video.